Okay, I'll start very quickly. Hi, my name's Peter Linnell. I'm a SUSE Linux technical expert. Thank you. That's my colleague Brian Snyder, who's the state and local government representative for SUSE, Novell, and NetIQ business units. I live here in California, and before I came to SUSE as a Linux technical specialist working with our sales folks and our customers, I worked at a company called Cloudera. How many people, why is this, oh, it went to sleep. Of course it went to sleep. How many people have heard of Cloudera? Okay, and how many people have heard of Hadoop? Hadoop, H-A-D-O-O-P, okay. Before I came to SUSE, I worked on Hadoop, and I'm part of an Apache software foundation project called Apache BigTop. So, unlike perhaps all the other speakers, I'm one of the guys that actually builds big data stuff. And I've been involved in it for a while now. And been in technology for a lot longer than that. So hopefully I'll give you a very balanced and realistic picture of what challenges and opportunities exist in government. And I'll talk a little bit about what it takes from an operational standpoint, from a political standpoint, to have a successful project and derive real insights from your investment. That's a particular challenge. If any vendor comes to you and says, okay, I want you to invest X in this particular solution and you're going to have a return on investment of Y, that's when you perk your ears up. My strong feeling is you'll never get a good estimate of a return on investment for big data investments. You actually get them in place. It's almost impossible to calculate. I'm going to start off, as I always do, with Dilbert, because Dilbert has the appropriately cynical and jaundiced view of the IT and management of today's corporations. And I think it probably applies as well into certain state government functions and agencies. Dilbert's always good like this. And the other thing is, big data is like teenage sex. Everybody talks about it. Nobody really knows about it. Nobody really knows how to do it. Everyone thinks everyone else is doing it, so everybody claims they're doing it. And it's true. The number of people that claim they're big data experts and really are is about a 1 to 10 ratio. And that experience comes from actually knowing how complex this technology is and how long it takes to learn to get your head around it. One of the things about big data, everybody heard, this is the Gartner hype curve. You've seen this, the hype cycle curve. Where's big data? It's, did I push the right button? It's right here at the peak. And that's last year's slide, so it should be up here, right along with hybrid cloud computing and cloud collaboration services and all that stuff. You got a technology trigger, the peak of inflated expectations. There's a trough of disillusionment, then the slope of enlightenment. The plateau of productivity, that's usually a 1 to 3 year window depending on the technology. So where is big data today in terms of maturity and technology? It's getting there. It's still a heavy engineering lift to get a big data solution working properly and to see real results from it. I'm a Linux guy, we're a Linux company, and Linux is the foundation of big data. And why? Because it scales. The largest supercomputers in the world, the vast majority of the large supercomputers in the world run Linux. It's low cost, you can run it on commodity hardware. There's no lock-in and co-opetition. And why do we have a picture of a bunch of guys leaning over screens? Because that's the Linux guy right there. Me and a Microsoft guy there, and a guy from another Hadoop distributed company called Hortonworks, and Cloudera, who are nominally complete ferocious competitors. All these guys are all engineers, and they all like each other and all work together. So there's a level of cooperation even as they compete. And that happens in the Linux space as well as many other open source technologies. And I love questions. And in fact, when we do our Linux Roadshow, we bring a whole bunch of swag, put it in front of the table and say, Yeah, you can have the swag, but you got to have a good question. So the best questions get the best swag. So I'm open for questions, and it doesn't interrupt at all. Big data's got a lot of momentum. Big and VC money is getting sprinkled all over the place. It's a huge amount of money getting sprinkled into the big data space because people are seeing that this is actually a technology that's going to pay off in the future. Now there's one of the eye charts and the complexity level of what you're about to embark on if you haven't embarked on a big data solution. That's a landscape of the databases that you could put into a big data solution. It looks like the London Underground train, doesn't it? And basically, why you want to look at it is you can see there's all kinds of different types of technology and what you use them for and how you apply them. That's a big part of the solution going forward. It's considering those. Now, I don't expect you to figure out the 70 or 80 different types of technology, and that's why you need a good consultant. And good consultants are scarcer than hen's teeth in the big data space. The ones that really know what they're doing, it's a hard find. When you talk about big data, it has its own jargon, it has its own kind of vocabulary. So before I talk about big data, the first thing I do is put that up. Hadoop is the core Hadoop is two parts called MapReduce and HDFS, which is a special file system. That's the data operating system. That's the kernel that makes all this big data magic run and work. Everything else that surrounds it, and some of the diagrams you'll see, I did kind of an exploded diagram of what a big data solution is. That's the middle part, that's the engine. It's like the kernel when you start up Windows or Linux that makes the thing tick. Now, Apache Hadoop is something else. Yeah, Hadoop's developed at Apache, but Apache Hadoop is a big ecosystem. It's a whole slew of different projects that are open source, some sponsored by companies, some have come out of Facebook and LinkedIn and Netflix and all these other companies that are standing up that have got big data sets and big data challenges. And my Apache Big Top project is one of them. The NoSQL, it's also called New SQL. It's basically a way of storing data, mostly in memory for quickly searching data. And there are lots of NoSQL vendors out there, and some of them have a different angle than others. For example, MongoDB is a company that has a particular NoSQL database that's very popular right now. And what application would you want to put Mongo in? You want to put that in when you're doing lots of textual search. You want to dump every PDF in your document repository into a database and be able to search it. Mongo works. If security is an issue, then you need to use something called Cumulo. Those are just two examples of 15 different flavors of NoSQL. So you need to know exactly the application before you start choosing these technologies. And in the big data space, we think of data as temperature. Cold data stored nearby, like on a tape archive, for example, or on a secondary storage. Hot is in memory. Anybody heard of HANA, SAP HANA? This morning? Okay. SAP is all about hot data, and that's why it's expensive. It's really good, and when you do a HANA installation right, the customers I know that have HANA love it. And I'm also proud to say that SUSE Linux is the only operating system that runs on. You go to SAP and say, I want to run it on Solaris, or I want it on Windows, or I want to run it on an OS X, on a Mac, and they'll say, I'm sorry, it only runs on SUSE Enterprise Linux because of the development costs and speed that they wanted to get HANA out. Live data is accessible to big tools, so it can have any one of those temperatures. But notice the most important thing here? Dead data is archive data. It's dead. It's useless. Once it's off your systems and inaccessible, it's useless. So in the big data way of thinking, archive data sitting on a tape somewhere is dead and useless. And now, and one of the things that big data folks kind of reach for and look for when they put these solutions together and as they talk to companies and architects about how to actually make this stuff work, one of the things that's really important is the idea that you never throw anything away. Like Google never throws anything away. Why does our Google Mail account keep growing and growing and growing? Because their theory is never throw anything away. even your trash when you delete it. There's another bit of jargon called ACID, autonomous, I can't even pronounce this, and I speak 2 languages. Atomicity, consistency, isolation, and durability. You'll hear a term sometimes bounced around called sharding. Just go to Wikipedia, look it up. It's too complicated for me to tell you right now. The big data challenges in government. We know you've got workflows that are siloed. You've got a lot of disparate systems because a lot of government software is custom written, specific to agency needs. You got sensitive data concerns and legal issues. That's certainly a big concern. You got regulatory blockages that prevent you from using data that could be useful. You got budget constraints. We know the state here in California, while doing better than other states, it's not exactly, it's still got large debts and the planning lead times. However, the opportunities are clouds. We know we're talking about cloud and all that sort of thing. Big data solutions work really well in the compute on demand model. And big data solutions are batch oriented, just like mainframes used to put the cards in, and then the job would be done. Big data works often like that. Much, if not most, of the big data platform is open source, so there's no vendor lock-in. And that's a really important point to think about going forward, because these technologies are evolving very quickly. And if you're not on an open source platform, you're going to find lock-in is a difficult thing going forward. But it also enables providing new and innovative service for end users, as well as helping with better informed decision making. These opportunities provide us the opportunity to share data and compute power in a new and less expensive way. And allows, if you do it right, for agencies to concentrate on their core competency, not run an IT shop. The big question here that you need to also evaluate is to cloud or not to cloud. Do I want to put my big data solution in the cloud or not? That could be a whole 45-minute discussion. I'm going to Los Angeles to give a talk on that very subject next week. The bottom line there is, my opinion and that of many Hadoop engineers is you put big data solutions in a cloud only when your data is already there, or for test and development and prototyping. Aside from that, if your data is local, you definitely want to have it running on bare hardware and not virtualized. And despite what other vendors may tell you, we Hadoop engineers work on code to squeeze the last 5% of performance out of Hadoop itself. And in fact, Intel has done a lot of work and contributed back to the Hadoop ecosystem to enable encryption and enable Hadoop to run very fast on their newest processors. So my point is, think about having it on bare metal, on real hardware. These are examples of big data volumes, whether it's scientific measurements, financial data, medical data, which is interesting for the state and for agencies. Indexed web or social media content. Environmental records like weather. Web server access logs are interesting for big data, and sales data. But we don't really sell much as far as the state's concerned, but it's still relevant because it shows economic activity. The 5 uses for big data is transparency. You want to find out what's going on, and it gives you new insights. And almost every single customer I've seen that has implemented a big data solution has found, what they found was, they found insights they never expected to have. And that's always a very interesting part of having a big data solution as a part of your infrastructure and your IT. It's really great about decision testing. Okay, what happened or will happen if we did or do this, make this kind of decision? Individualizing in real time, offers and services and customers. This is a perfect example of big data. Go to Amazon, you click a book, and then it comes up with a suggested list of books. That's big data magic behind the scenes. Who here is on LinkedIn? Okay, now you connect to somebody and then that page comes up and says, oh, these people might know you. That's big data behind the scenes. That's what we call social graphing. It's a technique used in big data solutions. It makes a connection between A and B and says, maybe there's a connection to C somewhere between these two. process control and automation. How cool can that be? There's an oil company up in Alberta that invested heavily in a really intelligent business BI solution. And it's so smart that it automatically downloads the prices of oil in near real time. And then it calculates from that. It actually changes the valves in the pipelines and says, okay, whoop, I'm going to put this oil on a train because the price is better. Or whoop, I'm going to put it in a pipeline and send it to the West Coast to get sent to Asia. That's what an intelligent process automation is all about. And data-driven business models. Those are the 5 main use cases. So how do you distinguish between it? Terabytes, petabytes, or exabytes? I can tell you that the biggest stock of big data that I know of is at Facebook, and it was about 300 petabytes and growing almost linear by month. Structured data, okay, think about structured data as like simple Excel spreadsheet. You got columns, and you got rows, or unstructured data like web pages and PDFs. How complex is your data model? Is it transactional or not? Do you need ACID? That's that integrity test. What are the usage patterns? Are you doing just lots of reading and querying, or do you actually update and delete? The other one is, what kind of info do you need? Do you need it in real time? Do you need it in near real time or long delays to do deeper analysis? And a combination of all of the above. I'm going to go through this really fast because most everybody understands SQL. Who doesn't know what SQL is? Or a standard relational database like Oracle or IBM DB2. This is I want to explain some of these differences because this is important to understand why this new technology had to come about. It has no predefined schemas, it's fast loading, it's simpler, it's flexible. The real innovation about big data solutions, especially in Hadoop, is deriving information from exploring the real data, unformatted and unstructured. When to pick a Hadoop solution versus a regular database? You need scalability. You can scale HANA to about 100 terabytes of RAM today. That's the biggest system I know that runs HANA. And in theory, it can go to 256 terabytes of RAM. But somebody at SAP has to find a customer to write a check for many zeros to build that system. Then it'll get built. Complex data processes work well with Hadoop, whereas a typical database is optimized for speed, it has transaction integrity, and it can be used for interactive analytics. Hadoop's that big dump truck, it can carry a lot. A regular database is the Ferrari that goes fast, but it can't carry a lot. The strengths of Hadoop are big volume data, it's immense. It can pretty much dump anything. I always like to draw the visual picture of what can you do in Hadoop. It's like a funnel for data. You can put it all in there, just dump it all. Pictures, videos, Twitter feeds, anything. It all can go into and reside in an HDFS Hadoop file system. It's reliable. It's got its own built-in fault tolerance. It's hugely scalable. The biggest cluster of Hadoop is about 4,300 machines at Yahoo. And in fact, a little historical background. Where did Hadoop come from? What's this name Hadoop? And why all these funny names for these programs? Hadoop is the name of Doug Cutting's kid's pet stuffed elephant. That's where it comes from. Nothing more logical than that. And Hadoop, and Doug Cutting, by the way, is one of the smartest guys on the planet and one of the most humble. You'll never meet a smarter computer scientist guy who's more humble than Doug Cutting. Great guy. I worked with him at Cloudera. It's lowest cost, it's open source, there's no lock-in, and it's batch processed. So you can decide which jobs are a priority. What are the weaknesses? No, it's not very efficient at small scale. Real time is a challenge in the sense that HANA gives you near real time. It requires some skilled engineers and operations, and it's less mature than regular databases. And it has a very weakly defined user role in terms of data access model. Excuse me. What that means is Hadoop was never built with security in mind, so it's been kind of glued on top. That said, there's a lot of progress on the way, and Intel and a company called Squirrel have done a lot to make that possible. And Squirrel in particular supports the cumulative database, which is really, really great for security purposes. It's technology that came out of the NSA, and it has cell level locking, so it's very, very fine-grained security model. It's very good, very scalable. What about all these new NoSQL solutions? It can be a really cost-effective replacement or supplement for traditional proprietary databases because it's all open source. You don't have to pay Oracle a 5-figure license for each server. And there's several, and there's probably a dozen around. Mongo, Cumulo, Cassandra, they're all trying to solve different problems, and they all have different strengths and weaknesses to evaluate. Linux challenge. As much as I think Linux is great, it's awesome, it runs. Who has an Android phone? Anybody know what runs and what Android's made of? It's Linux. So Linux can scale to the size of a watch or to the biggest supercomputers in the world. But when you go talk to the IBM scientists, we're hitting the limits of physics in current technology. When IBM came out with its latest processor for the mainframes, it runs at 5.56 gigahertz. Now, a typical laptop runs at 2 or 3 with the Intel chipsets. And they can't pump any more electricity in to make it go faster because they can't shed it fast enough. So modern mainframes have these exotic cooling systems so that they can run those chips that fast. And they tell me, we're hitting the limits fit. We need another technology to jump that bridge. Linux needs better fault tolerance to make it more robust. And the future will bring us what's called Exascale Challenges. We know that data doubles about, the data collected by enterprises is doubling about every 18 months. So when you think how that scales and what that looks like in the long term, right now the biggest supercomputer in the US is called Titan, and it runs on SUSE Enterprise, and that's why we talk about big data and big systems. And that does nuclear explosion simulation, so you can imagine the complexity of what it does. And it has 500,000 CPU cores in it. One of the things that's a challenge right now is when we get to that scale, we know things will break. So to jump to the next scale, which is millions of CPUs running in the same supercomputer, we have to account for fault tolerance that in a way we don't now. So when you get that many, you know X amount of CPU is going to blow up. You know that X amount of disks are going to die and X amount of memory chips are going to fail. We don't have that yet. It's a big challenge. And Java, which is the language which most of the Hadoop components are written in, has its own scalability issues. I was talking with an Intel lab guy, and he said, you know, when you take 1 terabyte of RAM and that's running a Java machine, Java does something called garbage collection. So once it does some work and then it wants to clear memory, it runs what's called a garbage collector. And basically clearing that can take an hour. So you've got this huge cluster, all this memory, all the systems running, and your stuff stops for an hour because Java has hit its limits as well. And stutter, which is mechanical stuff going on inside the CPUs, it affects Hadoop in the same way that it does financial transactions. This goes fast. I'm amazed how fast this goes when you're giving a talk. Is big data a solution in search of a problem? In some cases, what people need to ask is, do I need a big data solution, or I want a big data solution? No, 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 no. What I find, especially in companies, is I need to find these insights, and how do I go about getting them? And if big data is the solution, that's the path I go on. But it's not necessarily always the solution to go with a big data solution. Do you need real-time data versus near real-time? Now, who has seen Google Maps and uses it to look at the traffic? I think it's awesome. That's what you call real-time analytics, pretty much, or near real-time. Near real-time can be, I need to know this once a day or once a month, just like we do batch reports from our existing systems. Do we have the right questions to ask? And almost to a 1, as I said before, you find that people find things they didn't expect to find when they start using these kinds of analytic tools. Another big challenge, and it's probably even more of a challenge than in the enterprise side than in the government side, is how do we integrate it with existing workflows? It's a really big challenge because you've got systems that, that run in a certain way and have been developed over time for various and sundry needs, and now you're trying to plug this huge infrastructure into it and try and derive insights. It's more of a challenge because in the private sector, a lot of companies are trying to use this big data technology to leverage near real-time decisions and pricing and things like that, whereas here, we can, in the government side, I think we have a chance to be a little more analytical and derive a lot better insights out of it. What other agencies might have useful data? Somebody asked me, what about this big data stuff? Why would government get involved in it? And I said, well, I can tell you that if I were at the Department of Public Health, man, oh man, I'd have my hands out every direction I can get my hands on to find all kinds of data that might correlate to health outcomes. That could be anything from environmental records. It could be where a chemical plant's sited. It could be traffic reports. It could be weather, water testing, any one of those things. I'd want my hands on every single bit of that data I could. I know there's regulatory issues there, but that's the thinking is what other agency might have useful data? If I were, there's a nice lady here from the Department of Motor Vehicles. If I were the tax department, boy, I'd want my hands on the vehicle records for sure. And I lived in France, they did. And so if you went and bought a Mercedes, the tax audit folks really wouldn't bother you very much. But if you bought a Jaguar, it's almost guaranteed they were going to have a little second look at your car, at your income. Hence, Jaguar sales suffered really, really because of that rumor about the French IRS. The last thing I can tell you is pilot, and we'll run pilots and pilots and pilots. When I was at Cloudera, the most successful customers that were the most successful with their big data solutions were the ones that did a lot of testing, and they ran a lot of different pilots and evaluated a lot of different things. They didn't just say, okay, this is my solution, write an RFP, this is my solution. They had to do a lot of testing and a lot of pilots because they found out things they didn't expect. Plus, it's the learning curve of your internal IT folks learning how to deal with this technology, which is somewhat different than, say, plugging in a SharePoint system. It's a very different kind of way of doing things. So think pilots before you run things into production. And because I think it's important, I can't emphasize this enough. Run pilots. You'll learn a lot from those. So the 30-second pitch, why are we here? Because that's our big data partner ecosystem. As I said before, HANA runs exclusively on SUSE. We work with all the major Hadoop distribution folks. We're tier 1 supported. You take, and if you decide you want to run Cloudera, Hadoop, you bring it in-house, the installation is absolutely spotless, seamless, because we work with these folks. It just goes up. I can go from 0, and I've done it. I've taken 50 servers and gone from nothing on the servers to install Hadoop cluster running in 2 hours. That's the integration work we do with these folks. Why about SUSE? Well, we just think we're a really good foundation for big data. And the reason being is we have a really awesome history about high performance computing and supercomputing. People say, well, you're faster than the other guys. No, but I'd say, no, I don't know, because nobody really knows how to do good benchmarking. And if you do the benchmarking, it all lot depends on the hardware and the BIOS version, all that stuff. It's very hard to replicate and get good benchmarking for Linux performance. What we do know, and what we can say, is we have the scalability issue knocked on its head. The largest single image Linux system in the world runs down in Pittsburgh at a scientific lab, and it runs a single image of Linux, just one kernel, one machine, that has 16 terabytes of RAM in it. And when they get the budget, it's going to go to 64 terabytes of RAM. Just one single Linux instance, not a cluster, just one machine. That runs on SUSE. And a lot of this cooperation comes from the way we work with folks like Cray and SGI especially. Those are the guys that provide those monster supercomputers. We have a great relationship with them. We have the most modernized, optimized kernel for big data workloads. It handles memory really well. And we care about this market. We think it's important. So that's why they pay me and we sponsor to come here and talk to you about it. Because we know that I know the customers that ran on Cloudera and ran on SLES ran great. It just works. So questions? Shoot, go ahead. That's a really good question. One that the Facebook guys won't tell us about. Repeat the question. The question is, when you've got these massive databases, how do you back them up? How do you back them up? And I think that's a really good question because it is one of the challenges. Google won't say what they do, and Facebook won't say what they do, but I'll take a guess at what some of what they do is part of the Hadoop file system, which is called HDFS. It sits on top of a normal file system. It has its own fault tolerance built in. And the other reason I said you want to put big data solutions on real hardware and not virtualize them is because these big data solutions are actually smart enough to know which machine they are in a rack of machines. They actually know the distance because they spread the data across those clusters. So there's, by default, 3 copies of the data sitting in the Hadoop cluster. That's one thing. That's why it's very, very resilient and fault tolerant. Some of it can be done with compression, and that's the other part of that sharding question. But go to Wikipedia. I'll put you to sleep if I start talking about sharding. Goodness, we'll hear snoring in 5 minutes. But good question. Any other questions? Which I would tend to believe, without having seen it, I would tend to believe you. Yep. Good question. And the question is, okay, we've got all these disparate formats from FileMaker Pro to Excel to Oracle to IBM DB2. How do I get this on big data? How do I get this in a kind of a shape where I can actually make it usable? Well, fortunately, Hadoop, because it's open source nature, has 1 million connectors to it. And there's connectors for pretty much everything in the sun. As long as it can talk to ODBC, you can pretty much slide it into a Hadoop cluster if it can talk to. And there's specialized connectors which optimize the, we call ETL, extract, transform, load, that are specifically made to extract that kind of stuff and get it onto HDFS, so then you can use the big data tools to go to work and go to town. Okay, what about a mainframe? There's another tough question. People who may or may not know what mainframes are about, the way they store their data is completely unreadable on a normal PC. It's not ASCII, it's something else. Say again? Exactly. That's another acronym I really have a problem pronouncing, even though I speak 2 languages fluently and a 3rd one badly. I can't pronounce that one. In any case, now, and I would love to discuss that later, there actually are solutions now to get stuff out of your legacy mainframes and into a big data system. What we actually do is we run Hadoop on a mainframe. Wow! Running Hadoop in a mainframe. Why is that? Because the default operating system for a mainframe is called ZOS. But guess what? Linux runs really awesomely on a mainframe, and you don't pay what's called a MIPS charge. So you can take all that legacy, and sometimes the stuff's on the mainframe is the most critical, and the most valuable data is on the mainframes. What you do is you basically take it and extract it. This tool is called Veristorm. It extracts it from brain cramp, IMS, and all the other native formats that are on a mainframe, and lobs it into a virtual machine running inside of a mainframe, running Linux, and it's fast. They did a test to see how fast they could do, how fast it would run. The minute I came to SUSE, they gave me access to a mainframe, which I'd never used before. I thought, okay, play with this. Once I learned what a mainframe's about, it's really cool. They're really weird machines. Mainframes have the most exotic technology under the hood in the hardware. And they have a user interface that looks like it came from 1965. The first time I looked at the mainframe and I got playing with a 3270, I said, this is interesting. It's got these nice acronyms. It looks like the lunar module simulator that I run in Flight Simulator. All these weird acronyms and buttons and AS and A. What's this all about? But that said, mainframes are going to be around for another 30, 40 years. They're not going to go away. There's nothing like them with the reliability. And to IBM's credit, they've really done a good job of modernizing. You can take, as an example, 1,000 Linux virtual servers, or even hardware servers, blades. You can take 1,000 of them and put all of that data and all of that info inside of one mainframe. And if you're running Oracle or some other expensive database products, you've just gone from 1,000 licenses of Oracle to 1. That's the great thing about mainframes. And when you run Linux on a mainframe, it runs at full speed all the time. So you get maximum power and you can really run them hard. So yes, there are solutions for mainframe, because I know government has mainframes and I know there's a lot of legacy data there that's hard to get out. There is a solution. Question? Do I have an answer for you? It depends. There's no one way. I think there's another really important thing to take away, if I can get you to take away from here, is there is no one size fits all solution. That's really, really important to understand. When you're talking to vendors, they'll say, oh, well, you need X and you need Y. You really have to think, what are the core values and core objectives when you start implementing these things? What do you want to get out of it? And that's where you start your evaluation going forward. But how you do it, that's why you call me and say, who's a good systems integrator that I can trust and work with? And it would be specific to what the technology you're using. I mean, if, for example, I know if somebody, for example, your agency wants to work on like social media trends and log analysis of your web servers and your external facing customers, if you're an enterprise, I know exactly who to call. And they'd be really awesome. In the case of agencies, that's a tougher call, because I think there's a lot fewer experts with good government experience, even of those slice of good consultants in the Hadoop space and the big data space. But it's a case by case. That's the hard part. That's the part where the consultants really make their money, and they earn it. Any other questions? Sure. That's okay. That's the magic of Hadoop. It can use unstructured data. You don't have to alter it. Dump them you get two choices. Dump them into HDFS or put them on MongoDB, because MongoDB is a really awesome text searching functionality. That's two different ways. Yep. Yep. As fast as the pipes in your network are, you'll get the data landing on HDFS. And from a hardware perspective, yes, if you're going to invest in hardware, that's one thing to really pay attention to, is don't cheap out on the network side. Buy the high-end networking gear. You'll get a lot more performance out of it. Mellanox, which usually makes the networking gear that runs in supercomputers, very fast stuff. They did a white paper, and I read it, and they did it working with us on SUSE, and the performance gain just by adding good network cards versus, you know, commodity stuff was dramatic. So you can actually use less powerful hardware and less powerful processors if your network's good. Any other questions? Did you learn anything? Were you surprised by anything? What's the most surprising thing you learned today? Come on, don't be shy. I've got yo-yos to give away, by the way. I completely forgot. That's partly the fact that I'm from New England, and I love it out here in California, by the way. I'm a native of New England, and we're like the New Yorkers. We're very blunt, very direct, and people say, what's it like out there in California? I'm like, they're too nice. No, so so yes, I've always been like, this is the way I see it, this is the way I call it, let the chips fly. And that's just, I guess, part personality. Question? In a shared, sorry for being so loud. In a shared environment, yeah, there's a good case to be made for it. And in fact, in Hadoop itself, there are tools, it's called WIR, that's built right into the open source platform to help you launch your cloud, launch your big data stuff on, say, Amazon or Rackspace or OpenStack or whatever. But my point is, if this is important data and you're really investing into getting it maximum out of it, you want to bring it in premise. Plus, you've got security issues with government data. I was talking with somebody today, and they're like, well, we're talking about going to public cloud and this and that. And I'm like, well, I was a lawyer. And mind you, lawyers are always cautious. My mother worked for a lawyer. That's their nature. That's what they're good for. That's why we have them. That said, from the performance standpoint, I would always want to run it on my own hardware. That's just me. And that's the perspective of, I want to extract and make this as maximum, give your system the maximum capacity possible. And you don't need powerful machines to run it. You're better to run 100 small, lightweight servers than to run 20 fast ones. That spreading them out with good network connections is actually faster and more productive. I'm talking with a company that we're working on. We'll probably have an announcement. It's called Servergy, and what they build these pizza box servers. They're literally small enough to fit in my backpack, and it's a single core server. Runs very low power, about 90 watts, something like that. And I want 100 of those to run Hadoop jobs because that will crank. Because the way that Hadoop is smart is spreading that jobs. It's not CPU bound. Big data is not CPU bound. It's IO bound. It's bound by how fast your disk go and how fast your network is. So that's where we're finished. He's giving me the, you're done guy. Thank you very much.